Hello. Well, thank you so much for joining us here today. My name's Ben Clinch. I am a CDO, Chief Data Officer, that is, and partner at Orteca. But I've held some interesting roles at a number of, fascinating organizations, banks, as well as telecommunication digital services companies. And I am a keen advocate of good data management and how that can improve so many different aspects through data fabric, data mesh, and now, most importantly, AI. And there are certain modalities I want to talk to you about today that can unlock benefit within your organizations and for some of your clients to be able to get far greater value. And I'm going to try and be ever so slightly controversial, because there is a bit of a challenge in the data community that we can be an echo chamber. And so I want to really inspire some thoughts in you, along with my dear friend Charlie, to sort of see how we can improve the industry together. So enterprises are built as silos, and AI is having challenges as a result. So I want you to think about that as in terms of, we have this incredible event today, and we've been doing data management and data and AI, arguably, for many decades now, and yet we still are trying to solve some rather knotty problems. And some of that is a result of some design decisions that we've taken as an industry and sought not to challenge over time. So I want to use this as a visual analogy that I would encourage you to use as well. I'm sure you've probably heard of this, but just a bit of a reminder. In 1878, the QWERTY layout was invented. So this is a long, long time ago. And of course, that was designed to slow us down, because the mechanical hammers in an old typewriter would get jammed if you were too good at typing. And we're still using those exact layouts on our laptops to this very day. And there are a number of different reasons why we might choose not to move away from a standard. But have we done it consciously, or have we just repeated the design decisions of the past? And I want to impress upon you that we may have done the same in our enterprises. And that's why so many of us are involved in integrations and data dictionaries and catalogs, and because as an industry, we chose over 50 years ago, in the 1970s, to organize our data in a third normal form format. And there are lots of benefits for that, but there are also some drawbacks. And I'm not saying that there's, I spent 15 years designing SQL databases, and I still interact and use them all the time. So I'm not demonizing them, but what I would say is we've inherited some challenges as a result of it. This is an excerpt from Microsoft's Northwind database they use for training and examples. But I just want to highlight, when I was designing those applications and databases, I was asked to create something for CRM or for billing or whatever, and each of those was immediately structured for the purpose of the functionality of that application alone, not for the wider benefit of the enterprise. And so we are actually encoding a particular worldview in every mini database. So if you look at suppliers, for example, that might seem like not an unreasonable data entity. But then, what is a supplier across multiple industries? Is it a supplier of a service or a physical product? Should you differentiate those depending on your business model, et cetera? You're encoding these kind of design decisions in every application. The other thing is third normal form, bless it, which creates and is forced to create fake concepts to be able to link various different tables together. So just to make many-to-many relationships work. So a customer may have many demographic characteristics, and a demographic may have many customers. So we're creating fake artifacts. Now, that's a problem, because AI looks at that, and actually so do humans, and go, well, what do I do with that? It's not really reflecting reality, and data is a form of encoding experience. And if we're being forced to use things that aren't humanly understandable or AI understandable, then that's actually a problem. The instances themselves are separate from the models. So that also creates challenges in terms of relevance and sustainability, and then conceptual, logical, and physical models that people are looking after. The other thing is change management requires taking down databases and all sorts of other things that increase complexity. And of course, and this is an important point, the portability of these data structures is really poor. From one system to another, it's really quite hard work. Now, we as an industry have worked around this, and we're not going to be able to get rid of these. And actually, there's a lot of benefit that comes. So I'm focusing on the challenges that we get as a result of these design decisions. But as I look at all of the awesome vendors that we have here today, there is an incentive to lock clients into those structures. Because if you have portability, people can move off your platform. And as an enterprise architect, I'm really involved in ensuring that my customers have great options. So we do need, and it's not to criticize people about their business model, but it is something that we need to bear in mind in terms of the incentives. The great quote from Charlie Munger, another great Charlie, of course, like Charles Ivey, you show me the incentives and I'll show you the outcomes. So are we incentivizing portability and investing in our customers' outcomes, or are we investing in locking them into particular specific environments? Now, I was, as I said, a designer of these kind of SQL databases. And when people say, well, why haven't these taken off? Well, if I'm a good touch typer and I know how to use QWERTY, I'm unlikely to want to change my keyboard layout. And I'm afraid that's absolutely human mentality. We will focus on what we're good at and continue to advocate that. But in the new world of AI, AI doesn't care what you're good at. It cares what's going to actually help us. And so we're going to have to reinvent ourselves and our skills and be flexible. When Darwin talked about survival of the fittest, it's the fittest for the environment they're in, i.e. flexible. Flexibility is an absolutely important aspect of all of this. And we're seeing some poor outcomes in the AI space. 95% of generative AI pilots in companies are failing, according to MIT. Even the heads of Gen AI are saying that there are problems associated with hallucination and that it's not living up to its promise. And when we look at the Gartner report in 2023, two of the top reasons for these failures are to do with a lack of trust and a lack of data. Now, unless you've been living under a rock, you'll be familiar with the hallucination problems that we have in the industry. So what I want to do is sort of blow up, well, what are the paradigms? I've been using backpropagation neural networks since 1998 when I was in a bunker in Bristol University doing my mechanical engineering. And as a technology, it hasn't wildly changed. I mean, it's scaled at the most extraordinary rate. But so I want to just sort of question a few things. We want AI to be artificially like us, like human beings, don't we? I mean, that's one of the great advantages. We want them to be human, a human that knows everything, is never wrong, and can do anything you want, i.e. not particularly human at all, especially considering of all of our subjective experience and knowledge and truth is subjective, not objective. So if you ask people what is true around the world or even across London, they will tell you very different outcomes. So the idea that you would set up an organization specifically to be dependent on, say, one human being that was massively expensive, did everything for you, and knew everything, well, that would be a massive, unacceptable concentration risk on a single human being. Why would you do that with AI? So actually, an agentic approach does make great sense. Connecting specialist AIs that work together as a team, like you would with a team of specialists in your organization. However, even agentic AI has some challenges. It's built to replace some forms of technology that, that we've and disciplines that we've been using for some time. But in many ways, things like MCP protocols, and I'm a big fan, by the way, don't get me wrong, are effectively building on that without actually learning the lessons of the past. And so while we can connect the pipes in a really smart way, are we doing it in a way that really has learned those lessons? There's some fabulous articles that uncover, if an agent is expected to suddenly understand how these data models differ between systems, and we haven't prepared it in a way semantically that makes good sense, they're going to stand no chance when a human that can reason better across these different paradigms. So there is a real risk that we've just reinvented the paperclip. I'm probably showing my age a bit here, but if anybody remembers the office paperclip, of course I'm being deliberately fatuous, but the point being, it shows great opportunity in agentic AI, but not if you can't trust it. So how do we improve that trust? There might be a better premise. So over the years, we've seen great improvements in terms of the richness in the way that we share information and represent it to be able to get better context. Data, as I mentioned, is a form of encoding experience. So the richer the context we can give that experience, the better. So I'm a big fan of this phrase. My dear friend James reminded me of this. Knowledge is knowing that a tomato is a fruit. Wisdom is not putting it into a fruit salad, by Miles Kington. Now, the point of this, and why I like this, is classifying something and how you use it are not the same thing. And the data management industry, in terms of preparing data for individuals and departments, has made a bit of a mistake, which also is proving a problem for AI. So everybody knows what a list is, but if you put a definition against a list, you've got a glossary, and that's important, so that we can actually standardize the definitions across an enterprise. But then, in terms of nesting those lists, or setting them up like a parent hierarchy, you get a taxonomy. And that's where an awful lot of data catalogs stop. And it's awfully boring to be part of conversations in organizations where people are arguing whether billing address is in the billing list or the address list, because that's a waste of your energy. It's not how reality really works. Far better is to represent it in a rich number of dimensions, like an ontology, a mind map, if you will, that enables you to be able to get the benefit of the taxonomical view, but actually genuinely represent knowledge and information in a way that's humanly understandable. Many people these days, I'm told, and my kids are included in this, learn using mind maps. Good old Tony Bazan, we probably have to thank for that. We can be smarter around this. And of course, when you put instances or values within that, you're effectively building a database or a knowledge graph. So with this, I want to introduce my dear friend Charles Ivey from AWS Neptune onto the stage and to talk to us a little bit about what knowledge graph and everything that I'm pointing towards. So over to you.
Thank you, Ben. Hello. Can you hear me? Everyone hear me? Good. Best to check these things. I just want us to take a little step back for a moment and try to consider really what data is and where it comes from, because we get caught up in the technological world by almost thinking too deeply too often about these things, I think. So I was just going to go through a little thought experiment, which is that we have a few statements here, or a question, or a few statements and a question. There's a chap called Bob, and he's on his holiday, and he wants to go to visit an art gallery, and where should he go? I'd probably argue that all of us understand those statements and that question, but if you really think a bit more deeply about it, there's a lot going on there. We have to understand, first of all, the English language. Then we have to understand how it's written. We have to understand what is a bob, what is a holiday, how do they relate to one another, what's an art gallery, and can things go anywhere, and all these different concepts. And we take it all for granted. And that's basically because we've been using a standardized way of sharing data for a very, very, very long time. And we take it for granted. Now, we want other language models to interact with us with this complex data model too. And we're very proud of these wonderful new agents that we've created to be able to do so. But there's a slight problem. The problem is we've been recording data for computers in a very different way. So if I want to answer this question, you go to the next slide, please. I'm not sure it's going to be particularly easy for me as a language model to be able to answer that question in an effective time frame. I don't know how many of you either. I'm sure there's many people here who've used relational databases extensively, but I bet there aren't many who could still answer that question from that real data model in the next 60 seconds. I don't know. I won't make you wait 60 seconds, but the point is, it's not particularly easy. So why should we expect language models that are trained on our way of communicating to be able to answer that question effectively that quickly? However, if this was represented as a graph, we can help Bob. He can get there on time, and he can go to the Louvre to see to see the artwork that he wants to see. And that's really all I wanted to try and get across, is that if we want language models to communicate and see answers in the way that we do and understand context and information, we need to represent data in a similar way. And that's what we do with knowledge graphs. Anyway, don't take our word for it. Ask the subject matter experts at hand. If you go and ask any of the any of the many language models, they'll come up with similar answers. They want to see ontological models. They want to see graphs of data, because just as it's easier for us to communicate with structured data, it is also for the language models too. There have been various scientific endeavors to prove this kind of thing. Some of our good friends who are here today from Data.World, Dean and Juan Cicada here, have published some benchmarks proving this. So again, don't take my word for it again. Speak to some other experts and they'll be able to talk you through how we've been able to prove that just by using these kinds of data structures to define schemas and real data models, we can increase the accuracy from LLMs by hundreds of percentages, even with traditional data sources.
This is fantastic. So I would actively recommend that you watch Juan's talk from Turing Institute, which is linked through if you download the slides. The other aspect is that Juan and Dean's benchmark, which is designed to be particularly repeatable, proved a 400% increase in accuracy on quantitative answers against relational databases with just a small investment of semantic modeling on the top of it. So we don't have enough time to show you all of that today, but we would really recommend, because this quantitatively demonstrates, and you can get it even more accurate when it's on top of a graph, of course. So that brings us on to the actual modality that we're here to discuss, Neuro Symbolic AI. Neuro Symbolic AI, combining the generative and creative capabilities of large language models and machine learning with the well-established reasoning inference logic of knowledge graphs, or symbolic AI. People often forget that graph is a form of AI and always has been. So just like the hemispheres of the brain, you wouldn't want to be entirely creative and hallucinatory to the point where reality almost was irrelevant, and you wouldn't want to be stuck in a situation in which you couldn't evolve creatively. So combining these two modalities enables you to be able to leverage the data within your organization, the logic, the business rules, as well as the incredible power of large language models. And neurosymbolic AI modalities, including GraphRag and others, enable you to be able to unlock those. Huge fan of building up small interoperable graphs across your organization that effectively are building one hemisphere of that brain. And the only way I would recommend you do that is to use common vocabularies and standards that, again, are well used across the web. And of course, we know, just as Charlie said, large language models have been trained on the web. More than 50% of web pages are known to now include JSON-LD snippets, which are a form of graph. The data product standard, or the dprod standard as well, has some fantastic metadata that you can leverage. And of course, I'm a big fan of FAIR, although it's a different FAIR to the previous gentleman, although I have no doubt what he was presenting was awesome too. So how do we go about implementing these? What I'd like to do is take you through an idealized workflow. But first, I want to talk a little bit about a three-tier architecture. Are people familiar with bronze, silver, gold, or three tiers? It's a fantastic concept, but there are many different interpretations. In fact, Peter Strengholtz's book actually really expands out beautifully on this. I don't know if you're familiar with his work on O'Reilly. I'm a huge fan. One of the problems with that architecture and using SQL and relational thinking is that people think they need to move all the data first into the bronze layer, then conform it in the next layer, and then finally, after they've gone through all of that work, finally get some value from it. So I'm going to show you, and of course, let me mention the problems associated with that. You're making a huge investment in moving data into a bronze layer, which can take a lot of time before you get any value. You're then having to conform it further before, again, you can get value. And finally, in the gold layer, which is a consumer-aligned structure, finally, you get to see if you move the right data in the right structures to see if there's value. And often, people run out of money by the point that they do that. Now, it's still a good way of doing things, but not the build it and they will come approach, where let's move all the data first and hope for the best. If you're familiar with Kevin Costner, and again, I am somewhat aging myself with the film of The Field of Dreams. He was encouraged by the voices in his head to build a baseball field in his farm on the basis that if he built it, people would come. And it's a charming movie, but it's charming because it's absolute nonsense. It's not how a business can possibly work. And that's part of its charm. We don't want to operate on a dream or the voices in our head. So, is there a better way? Well, absolutely. You do not need to move all the data first if you've got a more flexible architecture like graph to be able to build upon. Here's something a little bit better. You start with a use case. Not dissimilar to the beautiful example of the benchmark, you can build an ontology rapidly to be able to answer questions associated with that. And because large language models benefit from the use of RDF, you can export those ontologies and ask it to create synthetic data within seconds. So you can test, is this model going to answer my questions, my use case, before you've ever moved any real data? And at that point, you can say, well, you know what? I forgot this aspect of it. And how long does it take you to redo that? 5, 10 minutes, maybe less if you're as skilled as some of the esteemed gentlemen in the front row. But having established that that's going to be useful and create value for your business, you can then start to think about, should I productionize this? You can also, by using open standards and a standardized meta model, accelerate the beginning of it in the first place. So I would always recommend that. It also means that what you're building is interoperable, a bit like that page where we were building out those graphs into an enterprise-wide set of information. And only then should you then think about committing to moving data in a flexible manner so you can connect it to the sources, applying good data management standards like I teach at the EDM Association around DCAM and CDMC, applying data quality requirements and usage contracts, fixing that data at source, but only fixing the data you already know is needed to be fixed, rather than fixing it all before you move it into the landing stage, the bronze layer. You can deploy measures to make sure that that keeps a sufficient quality for the purpose that you have. And that means that every time you are adding those use cases, you are building out the enterprise-wide view in a scalable manner that is proven to not only work better in terms of analytic output, but also for the benefit of Neuro Symbolic AI. You are building out that capability of one of the hemispheres. And so, I'm just going to quickly sum up, which is, don't believe the hype. Well, actually, you can believe the hype. Just a little, but do cut through. If 95% of AI projects using large language models are failing, according to MIT, is there a smarter way to manage that risk? And I'm telling you there is. I'm not sure how readable that is, but think in terms of agents with bounded areas of context and responsibility. So you're not just allowing agents to be able to access your entire data set, but you're allowing them to be tethered by the ontology that you've provided for that use case. Just like you would in least privilege for real people. Think about multimodal AI. There are a lot of true believers in large language models that say you only need machine learning. And while it can get you so far, it's very, very clear it's still far away from the benefits in which you can truly rely on it. Metadata is a graph. So when we're doing data management, think about the Miles Kington quote. Are we thinking in terms of ontologies, or are we trying to endlessly force things into lists that don't make sense? So we're not really using structures that make good sense to describe our enterprises. And then finally, think about moving data and cleaning it and doing data management in a much more targeted manner so that you're getting value up front rather than having huge upfront investments that often peter out before you get the value. It's time for a new paradigm, and that paradigm of flexibility in graph will enable you to be able to de-risk and deliver that. And so with that, Charlie and I would like to thank you for taking the time, particularly at the end of towards the end of a long conference. I hope that was helpful. We would love to connect with you. These are LinkedIn QR codes, and hopefully we can continue the conversation with you. Thanks again.